In this video, you will learn how to perform preventive maintenance as well as troubleshoot and repair Elston Manufacturing's nose-mounted HLC heater product line. We'll begin with a brief introduction of the heater and its purpose, show you normal operating procedures, detail preventive maintenance, and diagnose failures based on certain indicators with explanations of the required repairs. The HLC heater is a thermostatically controlled electronic ignition propane heater. This heavy-duty, forced air heater is designed to be mounted on the nose of a trailer. It's aimed to prevent cargo freezing during transit while being exposed to cold environments. This 35,000 BTU per hour heater uses propane for fuel and is powered by either 12 volts DC truck power or 110 volts AC shore power. Heat is generated by burning propane fuel, supplied at 11 inches of water column, expelling burnt components to the outside environment while a blower transfers heat to the trailer via the heat exchanger. Next, we will discuss heater operation. While operating the heater on 12 volts DC, pressurize the fuel line by fully opening the propane tank service valve. While operating the unit on 110 volts AC, connect the extension cord to both the unit and the 110 volt power supply. Then pressurize the fuel line by opening the propane service valve. Next, verify the thermostat is set to the desired temperature for the trailer or truck body. Initiate the combustion process by activating the rocker switch on the control box. The green light will come on and the blower will energize. As the blower energizes, it activates a snap action switch. This sail switch is used as an automatic safety device that will detect if the blower is malfunctioning or underperforming. After the switch activates, the amber light will come on to signal the start of the ignition process. Approximately 15 seconds after the amber light activates, the gas valve will open, supplying fuel to the burner, and the igniter will generate a spark for approximately 7 seconds, attempting to ignite the fuel. Once started, the ignition control will monitor combustion until the thermostat temperature is reached. When thermostat temperature is achieved, the heater will perform a 3-minute purge that will cool down heater components and expel any unburnt fuel and exhaust byproducts. The heater will wait for the thermostat to activate again in a cyclical action. This automatic on-off cycling will continue as many times as necessary to maintain the thermostat temperature. To stop the unit, first, ensure that the unit is running and the burner is on. If the burner is not on, force the unit to start by temporarily increasing the thermostat setting. Once the unit is started, close the propane service valve. This purges or removes propane from the fuel line from the tank to the heater unit by burning it off prior to unit shutdown. Once the line is purged and combustion has stopped, turn the rocker switch off. The green light will go off. The blower will complete a 3-minute purge that will cool down heater components and expel any unburnt fuel and exhaust byproducts. After the 3-minute air purge, reset the thermostat to the proper temperature. Always use the rocker switch to activate and deactivate the heater. Do not shut down heater using the vehicle's ignition key. This can result in melted blowers and reduce the life of many heater components. Always turn the unit off before unplugging the 110 volt AC power cord. Now that you understand the typical operations of the HLC heater, we will inform you of preventive maintenance that is suggested to be completed in order to prolong the operational life of the HLC heater. First, we will discuss what procedures should be conducted on a yearly basis. Check the exterior of the heater for damage. Check that the door handles are in the fully closed position. Carefully inspect the propane tank, regulator, fuel lines for leaks or damage. Replace any damaged components and fix any leaks. All propane tanks need to be recertified for usage after 5 to 12 years worth of operation, depending upon the cylinder type, condition, and previous requalification method. All repairs, requalification, and/or rebuilds must be done by an authorized U.S. DOT facility according to Title 49, Section 180.205 of the Code of Federal Regulations. Check the return air inlet and the heater outlet for damage and obstructions. Remove any obstructions and repair any damage. Check that all mounting bolts and screws are tight, and check that all electrical wiring is securely attached and undamaged. Also check that electrical fittings going into the heater and control box are tight. Remove the burner cover and inspect the burner and the inside of the combustion chamber. Check that the screws for the spark electrodes are tight and that the wires to the spark probes are securely attached. Clean any dust or dirt from around the blower and the air inlets and outlets. Check the exhaust outlet for carbon deposit and clean the heat exchanger if significant deposits more than a film are present. Start up and run the heater for 5 to 10 minutes to check that all components are in working order. Check to ensure heater is not smoking or producing soot. Report any issues found during annual preventive maintenance with the supervisor and devise a plan in order to correct any operational issues before approving the heater for usage. In addition to the yearly maintenance just described, additional preventive maintenance, to be described in a few moments, should be done on a every other year schedule. Remove both spark electrodes and check for damaged end deposits. The metal component of the electrode should not be any darker than a light gray or have an excessively rounded tip. Inspect the porcelain portion of the electrode for cracks and damage. If the spark electrode is damaged or excessively round, it needs to be replaced. If deposits are found, carefully remove them with a damp rag or an abrasive pad, such as an emery cloth or a fine grit sandpaper. We will now focus on troubleshooting for the HLC heaters. This section will identify commonly occurring issues and describe potential fixes. As with any product, certain unique situations do occur and will not be described in this video. If this guide does not help you fix your problem, please contact the company where you purchased the heater for more information. If you are unable to contact them or you need additional assistance, please call us at Elston Manufacturing toll-free at 1-800-845-1385. We will identify 6 common problems and the potential fixes for them. These common problems are: nothing happens when the heater is turned on, the green indicator light comes on but the blower does not run, blower runs but heater fails to ignite, heater usually ignites but sometimes it does not ignite, the heater drained the truck battery while the 110 VAC extension cord was plugged in to power the heater at night, the heater is producing smoke or carbon deposits are visible near the outlet of the heater. Problem A. Nothing happens when the heater is turned on. Does the green indicator light on the control box come on momentarily when you turn on the heater? If so, check the electrical connections in the heater and the control box for loose connections and the blower and the heater for obstructions. To check for obstructions, loosen the hose clamp on the blower and slide it off the combustion chamber. If there are no obstructions, the blower should turn freely. If the blower does not turn freely, it needs to be replaced. If the green indicator light on the control box did not turn on, check to see if the heater is running off of trailer power. If so, check the fuse and the line supplying power to the trailer and the 10 amp circuit breaker on the electrical cover. If the heater is running off of 110 VAC, check that the extension cord is properly plugged in. Check the fuse and the circuit supplying power to the 110 VAC and the 3 amp circuit breaker on the electrical cover. Problem B. The green indicator light comes on, but the blower does not run. Attempt to mimic blower operation by pressing on the activation lever of the sail switch mounted on the blower. Does the amber indicator light on the control box turn on, indicating the start of the ignition phase? If so, focus troubleshooting on the blower and the associated circuitry by checking the following list of items. Check that the 2 wires to the blower are firmly attached and there are no obstructions in the blower. To check for obstructions, loosen the hose clamp on the blower and slide it off the combustion chamber. If there are no obstructions, the blower should turn freely. If the blower does not turn freely, it needs to be replaced. Check the wiring connected to the electrical tray. Look for loose, corroded, or damaged wiring, especially at the power and fan terminals on the back of the ignition module, as well as loose ends of quick connections. Remove the cover to the thermostat and check that the heater is receiving at least 10 volts DC if hooked up to the 12 volt DC battery power, and at least 11.75 volts DC when powered by the 110 volts AC wall socket power. Voltages lower than these values indicate a problem in the electrical system between the heater and the vehicle, or the battery is run down to the point where the vehicle won't start. Start by looking for loose or corroded connections. If none of the above solve the problem, remove the blower and connect it directly to a 12 volt DC battery. If the blower runs, the automotive relay should be replaced. If the amber indicator light on the control box did not turn on when depressing the activation lever of the sail switch, this indicates that the sail switch is stuck open or the voltage to the heater is very low. With the power to the heater off, check the resistance between the 2 terminals on the sail switch with the activation lever depressed. Or on models with 3 terminals, the wire should be attached to the 2 terminals on the right side. Place your probes on these 2 terminals while depressing the activation lever. If the resistance measurement is anything outside the 0 to 2 ohm range, the sail switch is either stuck open or bad. Remove the blower and adjust the sail switch if it is stuck. If it isn't stuck, replace the sail switch. If the sail switch wasn't the problem, either there is a bad connection in the wiring supplying power to the heater, or the device supplying power to the heater has significant problems. If the heater is running off of 110 volts AC power, the 110 VAC power supply may need to be serviced. Using a digital multimeter, ensure that the 110 VAC power supply is receiving 110 volts AC and is outputting voltage at 12 volts DC across all 4 terminals. Problem C. Blower runs but the heater fails to ignite. Do you hear 3 trials of clicking noises with 7 seconds between each trial, 15 to 30 seconds after you turn up the thermostat? This sound indicates the heater running through its ignition phase. If so, check the fuel system, especially that the propane tanks contain fuel and that the service valve on the tanks is open. Confirm that the heater is getting fuel. Notice, if the ambient temperature outside is below 0 degrees Fahrenheit, the liquid fuel level of the propane tank must be kept at least 50% full at all times to ensure propane vapor can be produced fast enough to replace the propane being used by the heater. Check that the primary spark electrode's extension wire with the female quick connection is securely connected to the ignition module high voltage output. Check and verify that the secondary spark electrode extension wire with a number 10 ring terminal is grounded to the combustion chamber shell. Remove the cover to the thermostat and check that the heater is receiving at least 11 volts DC while the blower is running. A voltage below 11 volts DC typically indicates a low battery or a problem in the electrical system between the heater and the vehicle. If the voltage is below 11 volts DC, start the vehicle and let the vehicle's alternator recharge the battery for 15 minutes before attempting to start the heater again. If the voltage is still low with the vehicle running, there is a problem in the electrical system between the heater and the vehicle. Start by looking for loose or corroded connections. Check the sail switch on the blower. First, check that the wires are attached. With the power to the heater off, check the resistance using a multimeter between the 2 terminals on the sail switch with the activation lever depressed. The resistance measurement should range from 0 to 2 ohms. Also check the resistance between the rightmost terminal on the sail switch and the heat stud, the rightmost stud on the 4-post terminal block. Resistance should be less than 1 ohm. If this measurement is anything greater than 1 ohm, the high temperature safety switch needs to be replaced, or the wiring associated with this switch is loose, damaged, or corroded. Remove the cover to the combustion chamber and check the wiring for the high temperature safety switch. Check resistance across the high temperature switch. Anything more than 1 ohm requires a new switch. Check the primary spark probe. Remove the burner cover from the combustion chamber and the spark probe on the right side of the burner. The metal tip of the spark probe should only be slightly rounded. The ceramic insulator should have only light deposits on it, and the ceramic insulator should be undamaged. If the spark electrodes only have deposits, carefully remove them with a damp rag or an abrasive pad. If you did not hear the ignition phase processing, the ignition module may be malfunctioning and needs replacement. There's a diagnostic LED located on the circuit board of the ignition module inside the electrical bay. If the LED is steady on, the board has failed completely and needs replacement. Problem D. Heater usually ignites, but sometimes it does not. Check that the service valve on the propane cylinders is fully open. Occasionally, a tank will fail to supply enough gas to the heater unless the valve is fully open. Is any extra ductwork connected to the exhaust or air inlets or outlets? If so, the heater should have less than 15 feet connected to the inlet and outlet in the trailer. Any additional pipe connected to the exhaust should be 3 inches in diameter or more and less than 8 feet long with minimal bends, no more than one 90-degree bend. Disconnect all ductwork to the heater to see if this corrects the problem. If there is no extra ductwork, carefully check all the inlets and outlets and blower for debris and obstructions. Follow the troubleshooting suggestions for problem C, paying close attention to the section that deals with the heater receiving sufficient voltage while the heater is under load, and the section focusing on spark electrode physical conditions. Problem E. The heater drained the chuck battery while the 110 VAC extension cord was plugged in to power the heater at night. When the 110 VAC power supply has problems, the heater will switch back to using 12 volts DC from the vehicle by means of an automotive relay. Plug in the 110 VAC power supply and restore power to the heater. If the green light on the control box comes on momentarily, carefully check the wiring in the heater for loose connections. If the green light on the control box never comes on, check the power supply. Check to see if the green LED on the power supply is lit. If so, use a multimeter to check that the power supply is receiving 110 VAC and outputting 12 volts DC across all 4 terminals. If the power supply isn't outputting 12 volts DC across all 4 terminals with proper 110 VAC input, the power supply needs to be replaced. If you do not find any problems with the 110 VAC power supply, the control box or the electrical tray assembly needs to be inspected and serviced. Problem F. The heater is producing smoke or carbon deposits are visible near the outlet of the heater. Under normal use, the heater will deposit very little, if any, carbon near the exhaust outlet. These deposits are often the first sign of a problem with the heater or supply power issues. Deposits are an indication that the heater should be shut off. These deposits typically indicate that one of the openings in the heater is obstructed or the heater is not receiving enough voltage while it is running. Check if the heater is running off the vehicle battery only, with the vehicle not running. If the battery is significantly run down, the heater cannot receive enough voltage to operate properly. Running the heater for less time on battery or starting the vehicle should correct the problem. Check if the heater is running off of 110 volts AC shore power. Check that none of the inlets or outlets to the heater are blocked or any ductwork is damaged. The voltage at the thermostat should be approximately 11.75 volts DC when the heater is running with the 110 volts AC plugged in. If this problem persists when the vehicle is running or after less than an hour of running on the battery, check the following. Check that none of the inlets or outlets to the heater are partially blocked or any ductwork leading to or from the heater is damaged. Check that the heater is receiving a voltage of at least 10 volts DC at the thermostat while the blower is running. A voltage below 10 volts DC typically indicates a problem in the electrical system between the heater and the vehicle. Start looking for loose or corroded connections. Check that the regulator is producing the correct pressure of 10.5 to 11 inches of water column. This should have been done during installation. Therefore, it is necessary only if you have no records that it was done during installation or it has been a few years since the heater was installed. After you have corrected the problem, remove any carbon deposits present in the exhaust tubing. If problems reoccur, the air adjustment disc can be adjusted such that the heater will run leaner. Please consult us at Elston Manufacturing for additional information. Again, Elston Manufacturing's toll-free number is 1-800-845-1385.